So today we'll be starting with units and dimensions. So what is a unit? When I ask you how long is this pen, you might say 7 centimeter. The centimeter that you say after 7 is its unit. So that is the unit, and let's start with what are some fundamental or basic units. So first would be length, second is mass, third is time, fourth is temperature, fifth is electric current, sixth is luminous intensity, and seventh is amount of substance. There are two additional ones, two supplementary units. And those are radian and steradian. This is length that we already know. Mass is the unit of like weighing something. Time, how like what's the time you say it's 2 p.m. and if I say how long will it take for me to reach a certain place, you might say it will take you 30 minutes. So that's time. Then temperature you already know, electric current you already know, luminous intensity is something else. It's how bright a thing is. Then amount of substance you already know. Radian you're familiar with. The radian is something that is used to measure solid angle. Like you have normal angle, and if you want a angle in 3D, you use the radian. Then there is international system of units. So these 7 quantities, 7 units can be written in different systems. So the first is you can be asked to write length in CGS. So length in CGS system would be centimeter. So this is centimeter gram second. Then is FPS. Take a guess what FPS means. So this is probably second. In most of the cases, the last letter would be second. So this is feet, this is foot, this is pound, this is second. Then there is MKS. You might already be really familiar with this, meter kilogram second. And the last is SI. SI is something that you will be using whenever nothing is mentioned. So SI is again we'll be using meter kilogram second, and then let's start with dimensions. So you're familiar with all of this now. So a question might ask you, what's the dimension of speed? And what they mean by that is like, what is speed? So when I ask you speed, you'll say like 7 meter per second or something like that. So that would be meter per second. So in dimension, they are asking you, what's this thing? So this is the length, this is time, so this is the dimension. But you won't be writing it like this. You'll need to write it as an m to the power 0 because you don't have m here, L to the power 1, T to the power minus 1. So this is how basic dimension questions will go about. Then let's start with error. So there are two kinds of errors, systematic and random. So what are systematic errors? These errors can be either positive or negative. The sources of these errors are instruments, imperfection in experimental technique or procedure, and personal errors. Then random errors are the errors which occur irregularly, like the errors that arise due to unpredictable fluctuations in experimental conditions. Say the temperature rose a degree, so you couldn't have predicted that, right? So the errors which occur irregularly. Personal error is something like you might read something wrong, or you might be like you might have shifted the scale a bit while trying to measure it. So these are personal errors. Then what is the least count error? So least count error is the error that is associated with the resolution of the instrument. Like till what depth can this thing measure? So when I say a scale can measure up to a millimeter. So here is a scale, you have centimeter, so the least count of it is between like 14.1. So 0.1 centimeter is its least count. Then what is absolute error? So the magnitude of the difference between the individual measurement and the true value of the quantity is called absolute error of the measurement. So how do we find the true quantity? Like how do you know what's the exact one? So for that you are saying that let's take the average of all of our all of the experimental things. So that might be really close to what the actual thing is. So we take the difference of that and each quantity. Say we have A1, A2, A3, A4 till A9. These are our individual measurements, and then you can find the A mean, or the like really close to the original thing, as sum of A1, A2 till n divided by n. So for absolute error, you find the difference between A mean and AI. I is this, like I varies from 1 to n, and this is the measured value AI. It can either be positive or negative. This whole thing, this is the measured value, and this whole thing can be negative or positive. Then let's see what is mean absolute error. So for mean absolute error, what if I don't want my error negative? So here the arithmetic mean of all absolute errors that we got previously, we will take those, like we got absolute error was A mean minus AI. So this could be negative or positive, right? This whole thing. So here I would say that absolute error, this can be represented by delta A. Absolute error of 1 I'm taking mod of s. So I'll lead all of the errors in positive. And then I'll add them and divide them by n. So this is the mean absolute error. Then what is relative error? It is the ratio of mean absolute error to the true value. So relative error is delta A mean, that was this, divided by A mean that we found previously. Then what is percentage error? Percentage error is when the relative error, this, is expressed in percent. So this into 100, that's basically percentage error. So percentage error is A mean upon A mean into 100. So this is the percentage error, and that is all of the errors in unit and dimensions.